Super excited because we're kicking off the Vision series this week. I've got 3 days worth of really cool sessions. You can see the lineup here. We got Walt Disney Imagineering, we've got Industrial Light and Magic, we got Naughty Dog, Build a Rocket Boy, tons of great speakers coming. So let's get going because there's a bunch of really cool stuff to talk about. We will talk about some future stuff potentially. Please don't make any purchase decision based on that, but it's really cool stuff that we're got coming up and I want guys to share. My name is TJ, Senior Product Line Manager for the Entertainment Creation Products. But really what you're here for is this lineup, right? So we've got a whole bunch, as you can see here. First up, we're going to focus on rigging. So Will Telford, our product owner for rigging, will be talking with Wasim and Daniel, and he'll be going through some questions and answers. You'll be able to ask questions. So with that said, let me just get through a couple quick highlights and then really turn over to those guys and really dig into obviously some great talks. So if you haven't checked out Maya 2020, it's definitely worth a look. As you can see here, we're obviously got what we call serious effects with Bifrost. You can do a whole bunch of crazy stuff. Some of that's right from the viewport. In Maya 2020, we also put out over 60 animation features, right? So if you haven't checked out, that's actually a campaign with that line. There's a series that you can go and learn how to animate like that. But what we call intuitive workflows, but really trying to make it faster for you to get to work. So everything from animated bookmarks to a better graph editor, etc. And then as you can see here, GPU rendering makes your life a whole heck of a lot easier. And that's really our goal, is to make everything just faster so you can get in there and just do what you need to do. Well, that said, I know you came not to talk about this stuff because you can see all these things on YouTube already. So go check out the sessions if you haven't. We've streamed quite a few. And let's really turn over to Will, who's going to be talking with Wasim Khan from Naughty Dog. Lightsaber timer, over to you, Will.
So we're here with Wasim Khan from Naughty Dog. You're the lead technical director. You just wrapped up some amazing work on Last of Us Part 2. You've gotten to work on Uncharted 4. You've worked on Uncharted. So some of the highest rated games ever on the PlayStation. Thank you for coming on. I saw some of your viral tweets that you put out about your Last of Us work around the rigging work around Ellie. It was amazing stuff, so we had to have you here. As a technical director at Naughty Dog, what is it that you do?
First of all, I get to bridge the gap between art and technology, and my primary job is to design, create, maintain character rigs and deformation system, and also provide workflow tools for animators and character artists to ease their workflow. So I'm going to start with Ellie's face rig. So some technical specification, while I was creating this Ellie's face rig, we had some consideration coming from Uncharted 4 and Lost Legacy, and we had some workflow improvement that we wanted to do. One of the constant requests that I received from the animator that how we can improve our face rigs. And there are a couple of workflow that our animator was used to, and we started onboarding some new animators. So there is a constant debate about how should we approach animation controls. So there is one huge switchboard control that you have all list of attributes that you want to animate, and some animator likes animating on-face controls. So I wanted to find a best medium that will facilitate this workflow in more meaningful way. And using Maya's proxy attribute, I managed to create this rig that facilitate this workflow without disrupting any other animator. So they can animate with this whole list of attribute, which fax rig can get really extensive. In our animation rig, we had more than 100 channels to animate with, and it could get really extensive if you add more trigger controls.
So how are you getting this fax, which obviously looks like a blend shape kind of base rig? How are you getting that in engine?
So in engine, we don't support blend shape. So
Okay.
what we do is over the period of time, we kind of realize is I'm going to say smooth skin decomposition, and I will try to explain as we move along. But that kind of became our main workflow for exporting our data into a game engine. So what we do is we try to compound our layer of deformation into one single stack of skin cluster. So if you have blend shape skin in your workspace deformer, what we try to do is feed that data into SSD, and SSD will try to figure out the final compounded skin cluster that we can send into a game engine.
That's so
yeah,
cool.
in this case, like we had about more than 2,000 shapes, and we had 350 joints to calculate the final skinning for Ellie's face. And one of the approach that we took is generating this face rig is, I call it more of a data-driven face rig. Is we used to get, because we have this very talented team in San Diego that does scanning of the character, scanning all the fact shapes, and then doing retopo, remesh, and creating the final actor-based final shapes for our game characters. And that data can get really extensive. So the approach we took here is I used to get this huge list of attributes data from our other partner studios, and then this defines how the animation control is going to get built and how the combo shapes is going to get driven from the particular channels. And this led to a very smooth workflow to create this extensive cast of character and keep creating, because this process is a very iterative process. We go back and forth from the animator to shapes team, again back to TDs, generating that final data, sending to a game engine. And because everything we evaluate that supposed to be a final game data, so that turnaround is supposed to be really quick, and this led to that workflow in a very fast manner. So for the blend shape, as my first slide I've showed is like a 20K head. And what happens, we have this 20K head, and then we have this 350 transform that's going to drive the final scanning. What I do there is I literally find out which is the meaningful faces. I try to find the closest face that I'm going to use for riveting or joint to the face. And that means I'm going to care about technically only 350 faces. So what I do is I try to get rid of everything else that I'm not going to find it useful. That led to a couple of workflow improvement. One is the blend shape file itself was about 125 megs, and get rid of unused faces that reduced down to 23 MB. So that means more animators loading that data from server faster. They're not paying a cost or waiting to load 100 meg every time they reference Ellie character into the game engine. And with that 350 transform, I managed to calculate the final SSD skin for the final mesh.
Awesome.
So this is the quick example, because that rivet mesh is still live in Maya, and that transform that's going to get calculated in the end. So getting this final kissing scene was super complicated to get that into a game engine, but I can apply any world space reformer like softmod control or cluster, and then give it that handle to an animator to animate with. So same thing, you can see that some abyss of reaction with the ground.
Can you run any physics or anything on the joints once they're in engine?
Yeah, absolutely, and I think that could lead into our second conversation.
Okay.
So smooth skin decomposition kind of became a main workflow for our final deformation for the character. So like we knew when we were working on over the period of time on Uncharted 4 and Lost Legacy that it really works well on character faces. But in that case, all the transforms are baked. To get that tech working on our character rig, we wanted to make sure that rigs run runtime in game engine, because we have full body IK and we cannot export those 700 joints and bake that transform and send it to a game engine, because it's going to be really tough to manage in terms of animation memory. And we also introduced motion matching. So we wanted to have n number of possibility when we transitioning into a different state for the animation, and making that a runtime really helped to produce very cool effects. So there's a couple of ways we thought we're going to approach this one. One of the very useful ways, either corrective shape or PSD. Either you can add some sort of a blend shape or some sort of a deformer front of the chain or post deformation of the skinning. So that way you can add some corrective blend shape to get the deformation looking right. But the problem with that is you have to bake or create some sort of a deformer that works on a vertex level. The problem with that is we don't support blend shape into a game engine, so we wanted to find a more optimal way. And in case of Ellie, we had 20 outfits for Ellie for all different phases of the game, and then creating corrective shapes for 20 outfits, you can imagine the nightmare situation. So we wanted to find like how we can make this more artist friendly and more author, because in Naughty Dog we believe in iteration. We're constantly iterating on our character. So I knew from the beginning that I need to create a tool set that will help facilitate that workflow, able to improve and keep retouching our asset. And like we don't have any distinction between a cinematic asset or gameplay asset. Everything we author on highest possible LOD, and every mesh we have like 4 LODs. So we try to generate everything, all the skinning, all the low resolution meshes on the build time for free. So like we knew SSD had the answer. It worked really well for our faces, and we wanted to incorporate that into our body rigging. So this
Can
is where
we jump ahead and see? We really don't have a lot of time left. This 10 minutes is really tight time, but this dog rig is really cool. So you're using the same skinning decomposition tricks here that you're using in the face to drive the muscle and skin here, correct?
Yeah, exactly. So like in this case, like I have about a 56 on 138 deformation joint that gives you the final deformation for the dog. And it goes through multiple phases. So just want to give like quick rundown that how it goes through the pipeline. Just need a base mesh and a skeleton. And once we have the defined range of motion, artists can go and sculpt it, or you can generate the shape through some sort of a physics-based muscle rig. And these were the tool that I provided to the artist to facilitate that workflow. It goes through multiple steps. First step is finding out the error map. Error map is SSD telling you that it's trying to reach that goal and couldn't reach for those set of vertices, and I use that to generate the post joint, and those post joint then later on can be turned into a procedural rig. And then we go to the next stage, and those procedural joint can be turned into a physics joint if you wanted to. So it's a very artist-friendly and a very author-driven workflow.
Man, that is a lot of stuff. That's amazing that you got all that squeezed into 10 minutes of time. Thank you so much for coming on. We have a Q&A at the end of this, so Wasim and myself will be available for that Q&A. And we're both on Twitter, so feel free to come have a conversation with us there, because go check out those viral tweets. But thank you, Wasim, for coming on. We really appreciate you doing this, man.
Thank you so much, Will.
Welcome, Daniel. Thanks for joining us.
Thanks for inviting me to do this, man.
You were one of the best riggers I'd worked with. And now you're at Imagineering, and you're a media and pipeline manager.
You know, in rigging, you're solving a lot of problems kind of on the fly all the time. This just turned into a larger problem set to solve, with a larger variety of industries kind of feeding data together. We use just about every Autodesk product that you guys make, as well as a number of other products. And so we have to make sure that this data is available in all of those products as often as possible.
The constraints you have to deal with it being, you know, real world constraints, you're turning digital artwork into actual physical structures that people have to interact with.
As you start producing digital work, you tend to focus on the digital as if it's your final product, almost forgetting that, you know, in the time frame of a project at WDI, which is anywhere between 18 months and 5 years, that you actually have to build a physical building that is what you've designed digitally. You know, we make it happen. It's pretty amazing, the amount of work that goes into getting the attraction installed, getting it up and running, and the number of people that have to work together to get this all done is just mind-boggling.
One of your most recent projects has made a huge splash everywhere, and that's Galaxy's Edge.
I did bring some footage along of some animated figures that were in Galaxy's Edge. This animated figure was actually animated fully in Maya. You know, we rigged up the character, and the animator was able to animate this while the figure was in production. So they were animating this character prior to ever having a physical figure to test this on. Because we built tool sets in Maya for them to use to validate their animation against what we know the physical limitations are of the machinery.
So your Beauty and the Beast exhibit, when I first saw this, Belle's movement in here just blew me away, how fluid this animatronic is.
Yeah, and I mean, the really amazing thing is, obviously, we still have the mechanical limitations, right? Like, we still have to follow what is physically capable to be done, but these figures were amazing when they were done. This is for the Beauty and the Beast attraction in Tokyo Disneyland, and these figures, you know, we worked very closely with our WDAS partners in feature animation, and they kind of helped guide what these figures needed to do. They helped direct what the motion needed to be, and you know, the interesting thing is one of the animation directors actually made the comment that this motion is actually a lot more extreme than they would have done in the animation, but it's more extreme because of the fact that you're in a moving vehicle and you still want that readability of the figures. You know, these faces have 3 to 15 motors in their faces alone, and then some of them have up to 20 motors in their body.
15 motors in her face. Does that mean that you're handing animators 15 controls that are constrained by that motor?
We're actually giving them controls that they're more comfortable with, so they're not having to animate each individual motor by hand. We are then taking that animation on the control and manipulating the data on the way out to drive the independent motor data. I mean, if you look at the bottom right video right now, you'll actually see a screen pop up with the graph editor that we've created internally, and that gives them the ability to see what we call motor space. But this will give them a view into what's actually happening on the motors. In Maya, as well as on the figures directly, we're running a real-time physics rigid body simulation for 2 reasons. One, in Maya is to give the animator feedback. So they'll be aware of if they're colliding with anything in their animation, right? And the second is on the figure directly, because there are times where we drive the figures without Maya, obviously, because we're not leaving Maya behind in the attraction. We leave the animation profile on the figure. I have to say our animators are really great about that. They're fully aware that they are animating something in the physical world, and they are paying attention to all aspects of the figure.
What do the rigs look like that your animators use?
When we work with our partners, a lot of times we may even get some of the rigs they used in the films to start from. Having to deal with constantly painting weights or vertex changes or things like that actually get in the way. And so oftentimes right now, we tend to find ways to proceduralize outside of Maya and then attach the Maya end in a procedural way. With a lot of the stuff that you guys have added in 2020, even honestly, just being able to drive the matrix offsets that you have, being able to directly drive a matrix so it doesn't take over your translations, rotations, and scales is a huge benefit.
For people that don't know, there's now an offset parent matrix attribute that comes into every transform in Maya. Along with it, there's several matrix operations that can go in.
The caching operations you guys have added is a huge benefit. We're constantly trying to push Maya to its limits of speed. And I mean, right now, for us to stream animation to a figure, we actually have to block Maya's DG solves. So we basically cache all that up front, then we block it and we block the draw, and then we stream the data. And so now with caching, it's cached locally, so we don't even have to do our own caching system anymore. We can just piggyback on what's there, stream the data directly out.
Another area, which it's not in my 2020, but it's something we've been playing with, and you've had a chance to take a look at. Is we're continuing the procedural push as we look at deformation. One, we're looking at a more procedural definition of deformation membership, and then the other thing that we're looking at is a more procedural approach to weights.
Yeah, actually, the fact that you guys are doing that is really kind of huge for us, because seeing that getting built into Maya is great, because now what we can do is add those group procedurals outside of Maya so that when they come into Maya, they already have the group IDs built in. And what we can start doing is actually coordinating these group IDs and have shells that come in with the same group membership as the mechanical devices that can now be driven by the same joint without any intervention by somebody having to go through and manually paint these things. Being able to use volumes to weight things is huge, because now you don't have to manually paint this stuff. You can lay it out. You have it set up once. You're set up once. You're good to go. You can update that mesh under the hood as much as you want. And as you start making more available the original shape of a mesh, we can now start understanding what a mesh's original shape was, rather than only knowing what it was deformed as to start from. And so we can start targeting where our deformations come from in the chain. Before, you had to always turn off a deformer and then reapply a deform and then do this thing. And so you'd have to do this back and forth thing to get it to work. So you always started from the base shape. Now that you have this matrix input, how far can that get carried into the pivot? Because Maya has a pivot, but it has a rotation pivot and a scale pivot, and they're independent. Why doesn't just every node have a matrix input as its pivot? And now we can also understand what the original position is for a transform, which would be identity. And so at that point, you're now getting to a full procedural section of rigging where you now know your original position of every transform. You now know your original shape of every mesh. and you can just start applying deformations without the user's intervention in any way. You now know how to apply a deformation really fast.
In order to drive this proceduralism, rest state is extremely critical. Understanding the rest state of a transform and the rest state of geometry. Rest state for transform is not a first-class citizen. I have worked up some examples where I've been able to use the offset parent matrix to act as rest state. I had to maintain a lot of the calculations myself and the DG, but it was maintaining it. But what you'll notice in 2020 is several deformers have rolled out a new input attribute called original geometry. And that is the rest state of the incoming geometry. And because it's an attribute, you can always lie to it. You can pick any spot in your deformation chain and say, no, this is your original geometry. But what it's done is it's taken the different deformers that have their own notion of caching that are basically creation time caches. Like, all right, at the time I created this is the pose I was in, or at the time, and all that gets cached internally to the node, and it can't be edited, it can't be viewed, it can't be accessed. So it leads to people doing build scripts, which is destroy it and rebuild it. Whereas if it becomes an external attribute that's standardized across deformers, now you can plug this attribute in, and you can just keep a node around in your DG that holds your rest state. And you just make sure that your deformation chain is aware of that. So that's something we're very aware of, and that allows deformation, or rest state of geometry, to be a first-class citizen.
That's good to hear.
I wanted to thank you for making yourself available to us, and thank Walt Disney Imagineering for allowing you to speak with us about all this awesome stuff. Hey, it's good to see you guys. Thank you for coming to have this talk with us. We got some questions that are coming in on the live Q&A that I can just start feeding at you guys. So one of the first ones is for Wasim. When you're doing the skinning decomposition, which that answers another question. Somebody asked what SSD is. That's your smooth skinning decomposition. Are you using a machine learning algorithm for that, or an open source library?
No. So SSD, it is a type of machine learning that you feed into data, and then it try to find the best possible skinning solution. But it is based off the initial SIGGRAPH paper in 2012, and we're not using any open source library. But if you want to use it, you can find something called DemBones, and you can find that on GitHub. But the version that we are using, it's completely written by our TD back then, Hans Godard. So it is a combination of multiple papers combined together.
Cool. Okay. And then there's a question here for you, Daniel. They're talking a bit about your animatronics, and you'd mentioned some of the simulations that you run, and they're asking, hey, are there any tools that you're using to detect stresses from velocities, accelerations? Like, what kind of simulations are you actually running on these characters beyond maybe the ones you mentioned in that video?
Yeah, I mean, we've run quite a number of simulations, one being on the motion, just to make sure that that's within limits of what the motor can handle. But we do run quite a number of physical property simulations on the machine, on the motors, on the hardware, on the just the limbs and all of that stuff. But that's a different level of simulation we do than what we handle in Maya. That's usually more the simulations we handle from an engineering perspective, and the kind of safety measures we have to go through.
So when you're running those simulations, which of those have feedback loops to animation, and how real time is that feedback?
The feedback loop for animation is mostly just on the motor systems, make sure that they sit within acceleration and jerk limitations, and that's pretty close to real time. Again, because we were building our own caching system for that kind of stuff right now, it's a single threaded thing, so we do have to pre-process all of that so that we can play it back and scrub. But once we can start piggybacking off what you guys have in 2020, I think it should be near real time.
Cool. And then there's a question here that I can address. So the question is, can rigs built using offset parent matrix be exported as FBX to other game engines? So the answer to that is yes. Right now in 2020, you will need to do your own transform baking in order to make it more friendly to FBX. But we're looking at methods to make that more native part of the FBX exporter so that you can account for offset parent matrix upon export. So that's something we're working on, but it can be done in the meantime if you take it upon yourself to bake the transform. And then got another question for Wasim here. So it's about blend shapes, Wasim. So you mentioned that you're doing the skinning decomposition, to maybe to avoid blend shapes, or I don't know if it's the goal is to avoid them or if the goal is to just leverage skinning decomposition. But why is it that you're not taking blend shapes in Engine?
I think that's a decision we make early on because we knew the results that we're getting from SSD was like really extensive. The resolution with because that workflow is very flexible. We can define the number of bones that we want to use, and the skinning that generated from that bone, it's a very close to the blend step deformation. And I kind of touched upon in the presentation because we had so many outfits, and the number of outfits that we create for the characters it's a huge list. And if you take that approach, then you have to go and author that many blend shapes for that many outfits. And we also have like 4 lots for every character. So you can imagine the amount of work we have in front of us if we try to take the blend shape approach. So the skinning kind of provided that solution for us, SSD. And like I said, we author everything on the highest possible lot. So there's no distinction between the game asset or a cinematic asset. So when we author everything through SSD, we can, in the build time, we can choose the resolution of geometry that we can reduce, also the resolution of the bone. So we're also generating the skinning for our lower lot with SSD. So we can say our highest lot is with 700 joints or thousands joints, but lot 1, lot 2 can reduce down to 500 and 100 joints. So that way we can just keep generating new skinning through SSD, and we don't need to worry about any other different stack of deformers.
So with your SSD, with your skinning decomposition, you'd mentioned the face has 350 joints. So that's clearly not 350 manually placed joints, right? That's those. A lot of those are created as part of that SSD algorithm.
So for the face, because we knew the quality that we wanted to hit for Last of Us Part 2, that I manually went ahead and placed those 350 joints so we can get more out of the SSD. We can choose placing joints automatically, but the results can be very different for every iteration. So for this face rig, we chose that, hey, use this 350 set of joints for doing SSD. For generating body, that after producing that error map, that we know that, hey, this set of vertices are not reaching the goal to achieve that final skinning. On that iterative process, I can say, hey, you know what? Try to create 50 joints. No, now go ahead and create 100 joints, and then I can keep iterating that. How close are you to the final goal? And that way I can choose that, hey, okay, I think I can reach the same resolution with 50 joints instead of 100 joints. So that way I can export only 50 joints to the game engine, because again, we need to think about the data that we're generating that we're going to send into a game engine. If we choose 1,000 joints, it's going to slow down. We still want the game to run 30 FPS.
I gotcha. And we have a question coming in from a rigging tech art legend in my mind. I won't out him by name, but he's curious, what sort of algorithms are you using to drive those SSD generated joints at runtime?
So it was like a very iterative process because we're trying to invest into SSD for last 4 years, and the version of the tool that I've showed is like a third iteration of that tool. So the initial version that we tried, but think of it that in the end, what we're trying to do is once we figure out the roam and range of motion, that hey, those poses going to be turned into let's call it a pose space deformation. So instead of setting up vertices, we are setting up transform, and in the end we try to choose RBF initially, but the result was not that good, and the data that's being generated is exponential because, like I said, you can feed that how many joints that you want to create, and RBF can also get really extensive. So what I choose the last iteration is interpolating matrices. So once I figure out the space and the transform, then I just blending one-dimensional and multi-dimensional matrices to go into in and out of those poses.
All right. Well, it's time for us to move on to our animation section. Thanks for all those questions. Like I said, me and Wasim are on Twitter. I don't think Daniel's over there yet, but there was one comment for you, Daniel, that somebody wanted to pause your video because I think people wanted to study it. There was so much to unpack there. So great job, guys, with everything you did. And we'll go ahead and go over to animation now. Thank you so much.
Thank you.
Thanks.
Hey, everybody. That was great. Thanks very much, Will. Thanks, everybody, for joining us. My name is Mark. I'm the product owner of animation at Autodesk. We've got a lot to unpack as well, so I'm just going to jump right into it. First off, I'd like to introduce you all to Harvey Newman from Build a Rocket Boy. He has over 13 years of experience and many AAA titles under his belt. He's a seasoned leader who is incredibly passionate about animation and games. Currently the animation director over at Build a Rocket Boy. He's worked on some of the biggest AAA game franchises, including GoldenEye, 007, Crisis, Fable, Horizon Zero Dawn, Warhammer, and most recently Battlefield and Star Wars Battlefront 2 at DICE. You might also know him for his popular YouTube channel, Harvey Newman, All Things Animation. We've got a little example of one of his videos, and I'd like to roll that now. Thanks.
In this episode, I want to cover something that I feel there's a bit of confusion out there, which is the role of a gameplay animator. So in games, there is cutscenes and there's gameplay. And those two things actually work very, very differently. And I want to clarify what a gameplay animator specifically does, because I feel like there's a lot of confusion and it's time for us to actually get that out of the way. As you guys know, I love animation and I also love games. And I work for an upcoming company called Build a Rocket Boy. I'm gameplay animation director, and within this company I've been getting quite a lot of applications from different animators trying to actually get into gameplay animation. I genuinely think that being a gameplay animator is the most rewarding thing you can do, but you do need to have a bit of a technical mind as well as an artistic mind and merge them all together. The end result is fantastic. Obviously games talk for themselves. It's really, really rewarding to see your character moving around, doing the things that you actually intended it to do, but it actually requires quite a lot of work to see your animations moving around and interacting with the environment, the objects and all that good stuff. I want to take a few moments next to kind of explain what the role entails, some of the stuff that you're actually going to face as a gameplay animator, dispel some of the confusion going on around the role of gameplay animator, and also hopefully give you a little piece of my mind on why that role is so amazing. So, welcome to episode 38. Let's get to it. I've been 6 times, so I'm hoping my 7th is the New Orleans, and Brazil is still on my bucket list.
Awesome. So that's Harvey's channel. Go check it out on YouTube. We'll talk a bit more about that after this. But next, I'd like to introduce you all to Delio Tramontozzi from ILM. He's an award-winning animation supervisor in film and VR and theme park attractions with over 20 years experience creating dynamic action sequences and fantastical character and creature performances. His work has garnered critical acclaim, winning Oscars, VES Awards, and TIA Awards, including most recently Star Wars Rise of the Resistance. In his role as animation technology lead at ILM, Delio also works closely with engineers to design new tools and workflows utilizing cutting-edge techniques. Delio and I work actively together on the future of animation workflows, and it's great to have him here as well. So welcome, guys. Next up would be Delio's video. Thank you. Awesome. Again, thanks for joining us, guys. Welcome.
Most welcome. Glad to be here.
All right. So we've got a ton of questions, and My pleasure. So we have a ton of questions. We want to leave time, obviously, at the end for some live Q&A as well. But I'll just get us kicked off here. Number one for Harvey. So what got you started in animation?
Well, I actually, I always had a love for illustration and animation since a young kid. I started with comics actually, so I chose illustration instead of animation. But animation kind of was in the back of my mind all the time. So as a young adult, I realized as a comic artist, you probably just end up working freelance. At least was true back then. So I decided to actually give animation a try, since you can actually get a full-time job at that. So in West London University, like many years ago, I did a bachelor's degree on animation, and after 3 years, I was hooked. To me, felt great, felt exactly what I wanted to do, and it was one of those things that you kind of realize that you could do for free, but if people pay you for it, then you can just do it the rest of your life. So that's kind of how it started.
Awesome. How about you, Delio?
That's pretty solid. I guess my background is somewhat similar in that, probably groomed for this field from the start without even knowing it. Being a child of the 80s, if I wasn't playing soccer and baseball, I was running around with a lightsaber in hand, transforming robots, playing D&D, and drawing X-Men. So that really kind of sums up my imagination was just an overdrive. But I didn't even know it was a career, really. Similarly, maybe because my parents were immigrants from Italy, and it just wasn't within their orbit, right? It was like, when I was in college, I opened up the course book, and I was going for landscape architecture. I found a 3D computer animation course, and this was before Toy Story even came out. It was 3 years before Toy Story even hit big, so it really wasn't in the main psyche of the mainstream at all. And it just clicked. I was just like, all of a sudden something just went pow, like, what? This is an actual job? You can actually do this for a living? And that was it. I was sold. I went and got my graduate work at CalArts, and then the rest is history. So.
That's great. So yeah, obviously these guys have been at this for a long, long time. So get your questions ready. We'll get to them as we go. Next question up would be, what tools do you guys wish you knew about earlier in your career? I'll start with you, Harvey.
So tools in Maya, something that actually kind of changed the game to me, that is probably like old school for most animators nowadays, is layers. So when I started using Maya, there was no layers. So I used to always work on the base layer, as you know it now as a base layer. And you had to be very careful, and you had to create a whole bunch of files in order to try things out. So you had version 1, 2, 3, 4, 20 in order to actually try things out. Layers kind of changed the game for me, because all of a sudden you can actually just add a layer on top of animation, spend about 20 to 40 minutes actually kind of trying a few things. If it works, great. Just merge the layers back again, and then you're good to go. And yeah, there's so much more, and layers keep getting better. They become much, much more powerful as you go. Things are much more stable as well. So awesome. Yeah, I wish layers. That's definitely my jam.
Awesome. How about you, Delio?
For me, I'd have to say I didn't start when I jumped on the computer. Having gone to CalArts, thankfully I got some traditional animation experience. But when I got into the computer, I felt like I could touch everything all at once. I didn't have to like manage my drawings and parts of the drawings. So you break down and you start at the basic shapes first in traditional animation. In computer animation, you have it all presented to you right away. You have your hand controls, your body controls. You can start pushing things around immediately. And I know that when you're first starting out, you just want to get to that pose and you start pushing everything around, and you start to lose track of sort of your technique and your method. So I think for me, one of the biggest things was really figuring out a way of rolling and flipping in the computer versus traditional animation where you would take the papers and you'd flip them like so. So basically Maya has the hotkeys built in. I remap mine so that they're all on one sort of location of the keyboard, so I don't have to look down. But Maya's greater than and less than will allow you to flip back and forth the keys, and therefore I can evaluate posing, evaluate my gesture, my spacing, and the arcs of the action without having to render. So as I'm working through, I can see something moving, track its arc, whether it's a point on the wrist, a point on the back, an eye, a mouth corner. I would say that is an amazing. I wish I had sort of developed or known about right from the beginning.
Awesome. That's great tips, guys. Thank you. Let's see. Next question. So cache playback. Assuming you guys use cache playback in your workflows, how has that improved your workflow?
So for me, cache playback was a game changer. So what happened throughout my career is that depending on the studio that you work on and depending on the pipeline, rigs have a tendency to be heavy, especially like very complex rigs, which means that you end up play blasting a lot as you actually go through your shots. And as an animator, you don't really want to do that because that's wasted time. You actually want to be in the scene animating as much as you can. So as soon as playback came along, it meant that no matter the pipeline that you have, no matter the rig, every single animation runs at 60 FPS or 30 FPS or whatever, like natively. And that was a game changer for me. As soon as I started using it, it really doesn't really matter what rig that you have. You just allow it to cache and boom, it's amazing. Also, I video edit, so caching has been true for video edit for years. So as soon as I noticed that Autodesk actually was doing caching, for me it was like, I understand this, I get it, let me see how it works. Awesome. And awesome of Autodesk to make it work so well from the get-go.
Oh, that's great to hear. It's great to hear. How about you, Delio? Do you guys use it at ILM there?
Yeah, I gotta say, similar things. I'll just add to what Harvey said, which is, real time is critical for what we do. And, you can either throw numbers at a problem or you can work smarter. And the cache playback allows us to work smarter, where we can just evaluate our animation in real time. We had rigs on, for instance, like Teenage Mutant Ninja Turtles. These are hugely organic creatures with hanging, dangling bits of armor and rags. And, went from like 4 FPS to, like you said, like real time, 30 FPS or 24 FPS for the show. And we could have four turtles in the scene running real time. So yeah, immensely helpful.
That's great to hear, guys. Awesome. So again, I'd love to discuss all of these things in detail, but I want to get to as many as we can. The next question is keyframe versus motion capture. When and why do you guys use this in production?
So for me, keyframe, I worked in a few projects that keyframe only, and I worked in a few projects that are actually mocap only. And for me, like keyframe, definitely very useful when it comes to very stylized games. So Fable Legends is a game that I actually use keyframe for everything. Doesn't matter if it was biped or creatures. When it comes to games like Battlefield or Battlefront, actually Battlefield only, it's actually just mocap. Battlefront is actually a mix between the two. And that is actually a perfect example to actually kind of drive that idea of mocap versus keyframe, because a character like BB-8 or Yoda requires much more keyframe than a Vader will require, right? So they're both equally as fun, but it takes a little longer to do keyframe than mocap. So there's plus and minuses on both. Keyframe is also always more appealing to animators and more creative, but mocap has these strengths as well. So, and there's an art to mocap.
For sure. We are running out of time, so I'm going to jump into the next question for Delio. Favorite projects or shots? Different projects, favorite shots that might have challenged you.
I gotta say, working. Yeah, that's all good. The most recent is usually the one, right? But truly working on with WDI on bringing to life a new Disney park land is an opportunity of a lifetime. So what an immensely fulfilling experience it was to work on Rise of the Resistance, bringing that land to life, and that particular like capstone or keystone ride was just tremendous, right? So I have to say that sitting in a theme park gives you a chance to theme park ride, experience our stories and animation that so far is unmatched. You get that extra dimension that you just don't get when you're in the theater. So in that regards, it's just so fulfilling.
Awesome, very cool. Well, I think we're out of time. Do we have time for one more question? If we do, if not, we can bring everybody else in and wrap it up. And we'll bring everybody else in. Welcome, everybody. So that's it for questions for animation. I'll leave it to TJ to send us out. Thanks, everyone, for your time.
Yeah, it's really cool. I'm trying to read through the stream, and there's so many questions we didn't even get to. So we should obviously do more of these. But really appreciate everyone coming. Obviously, it's a star-studded lineup. We hope to get this all edited and posted soon. But as you know, we're doing a vision series all week, so that might be a little bit delayed as we go through that. But again, I wanted to thank each of the presenters for coming and spending their time, because obviously it's some pretty cool stuff. And like I said, if you have more questions, as Will mentioned, there's Twitter and different ways to reach out, and we'll definitely make sure that we'll do our best to answer all of those. So again, thanks for coming, everyone, and I appreciate your time, and have a good day.
Thank you.
Awesome.
Thanks, guys.
Thanks for having
Thank
me.
you.
Bye-bye.
Appreciate it.